it's Mrs. Glenn. Welcome to the 4.5 Solving Linear Systems by Graphing video. In this video, you'll understand how to graph two lines on one coordinate plane and be able to find the solution to those two lines. So let's get started. So the first question is, what is the system of equations? So the definition of that is two lines that are graphed on one coordinate plane that either share 0, which is none, one or more answers. So it depends on the type of lines that you're graphing, but they'll either have no answers that are the same, at least one, or maybe more, and I'll show you what that means. Next thing is, what is the solution to the system of equations? Well, the solution is the answer or answers that are the answers for both lines. So you're not graphing them separately, it's a system, so they work together. So the answers that we find have to be the answers to both lines. All right, so here are the three different types of solutions that you might get with linear functions. So these are called intersecting lines because they intersect each other. So just like the y-intercept intercepts the y-axis and the x-axis intercepts the x-axis, these two are intersecting each other. So those are called intersecting lines. These two are called parallel lines, which you've probably seen before. They will never touch each other. And so intersecting lines have one solution because they intersect each other in the center here. So that's one solution. But you'll notice here that these two are parallel lines. So there's no touching, there's no intersecting of any sort. So this one actually has no solutions. So you'll know it's a solution if they actually touch each other. So wherever they intersect each other, or if the two lines touch each other at either spot, then that's how many solutions there are. So parallel lines have no solutions because they never intersect each other. Then if it's the same line, you might not know it's the same line. Most of the time when you get a question, you'll know it's the same line if it has the same slope and the same y-intercept. So if they have both of these that are the same, then it's the same line. So therefore, it's infinitely many solutions. So infinitely many solutions. So that means every single solution for one of the lines is exactly the same solution for the other line because it's the same line. And then solving by graphing. All right, so make sure before you get started that your equation is in standard form. Oop. Come back, please. Oh, all right, guess I'm not deleting this. Make sure it's in standard form. I want to just delete that one, but we'll just leave it there. It might want to stay. It's going to stay for the video. So make sure it's in standard form. So if you remember what standard form is, it's y equals mx plus b, where m is your slope and b is your y-intercept. So if you remember, you had this little diagram on my board if you're in my class. Oop, that's not a good one. Let's erase that. Make it a little bit better. So it was y equals mx plus b. So b is where you begin on the y-axis because it's the y-intercept. And then m is where you move using the slope. So a lot of you think that the x is part of the slope. It's actually the x and y are just an ordered pair of the line. So it's just any ordered pair that's on a line is your x and y. The m, which is the number in front of the x, is your slope. And the b, which is the number by itself, is your y-intercept. So b, begin, that's where you start your line, and m is how you move it from your y-intercept. So let's show you what that looks like. All right, so number one is already in slope-intercept form because we have an x by, without any y next to it. Y is by itself and a number by itself. So we're going to start at -8. So we're going to count down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then our slope is actually a 1 that's in front of this x because there is no coefficient. It's automatically a 1. So that's going to give us a slope of 1. So the line is just a perfect 1 slope. And I should have a ruler, but I don't. There we go. And then this one is going to start on 1 because we begin with the y-intercept. And this is a -2. So remember, if you have just a regular whole number, we can put 1 underneath it. So that's -2 over 1. So we're going to go down 2 over 1. Down 2 over 1. And I like to actually go until the line crosses the other line, because then I can find my solution and I know I'm accurate. So you see how this red line is going to cut through the blue line right here? So down 2 over 1, and now I can make this line. Or try. There we go. Okay. Not very straight, but you get my point. All right, so here is our solution. So when you want to actually state the solution, you need to state it as a ordered pair, an ordered pair. So x comma y. So we're going to go over 1, 2, 3. So that's a +3. And then we go down 1, 2, 3, 4, 5. So 3, -5 is our solution. And you always want to like put a box around it or a circle around it so that you are showing that this is your solution to your intersecting lines. So this right here, this green dot, is the solution that if you plug x in right here, if you plug 3 into this, you get 3 minus 8, which is -5. If we plug 3 into this one, -2 times 3 is -6, plus 1 is also -5. So the solution is the numbers, x and y numbers, that work for both equations. And that's the whole goal of solving for systems. And this is actually my favorite topic in Algebra 1, is systems. I love systems. All right, so now we're going to move on to this one. This is already in slope-intercept form as well. So we're going to start with our b, begin with b. So we're going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to go up 1 over 2. So we're running out of room up here. But if we go backwards, we can go over 2, down 1. And it'll give us where the line started. You just kind of use the... You just go backwards a little bit. And we have this line. Whoa, there we go. I don't know what that sound was. Okay. And then y equals -x plus 6. So we're starting at 6. So 1, 2, 3, 4, 5, 6. And our slope is a -1 because that's in front of the x. So that's -1, which means we're going to go down 1 over 1. So this is a perfect slope, except for it's just a -1 slope. Down 1 over 1, down 1 over 1, and so on. And now I'm going to go back this way so that I can actually find where they intersect, which is at this dot. So now I make my line for the red line. Oh my goodness. Let's start again. Oh, that was bad too. All right, that's going to have to be what it is. Okay, so this is our intersecting point. So when we make our solution, remember it has to be in an ordered pair. So x comma y. So we're going to go over 1, 2. So that's to the -2 side of x, because these are the negative x values. And then we're going up 1, 2, 3, 4, 5, 6, 7, 8. So up a +8. So our solution is -2, 8. Remember, circle it, something to point out this is your answer. And that goes for the point that's right here. That's our solution. All right, on to the next one. Okay, so we have two equations. They are not in slope-intercept form, so we need to make this one in slope-intercept form. So I'm just going to rewrite it. And I'm going to have to add 3x to get it to the other side. And the reason why I'm adding 3x and not something with y is because we're trying to get it in slope-intercept form, which remember is y equals mx plus b. So we want to leave the y alone and move anything that's not y. So in order to move it, we have to do the opposite operation, or the inverse operation. So these cancel out. You're left with y on this side and 8 plus 3x. And just like the other video, you have a decision to make. Either put 8 first or 3x first. Well, I know we want to have the x value first for our slope-intercept form. So we want to change this to 3x plus 8. I just realized I gave you guys the wrong answer. We don't want this in standard form. We want this in slope-intercept form. Oh, okay, well, just change this answer to slope-intercept. Okay, back to the show. All right, so now we have this one changed to slope-intercept form. So we're going to start B with the B, begin with B. So 1, 2, 3, 4, 5, 6, 7, 8. And this is up 3 over 1. So up 3, 1, 2, 3 over 1. And we ran out of space on this one, so we're going to go down 3 over 1. Down 3 over 1. Down 3 over 1. And so on. You don't have to do too many, just enough to be able to create your line. And then make arrows at the end, and you want to extend out either side past the dots that you did. So that's our first line. And then our second line, again, we have to make it in slope-intercept form, so I'm just copying it down. So this is, our y is going to leave alone. We're going to do the opposite of negative x, which is positive x. You're left with y equals, x comes first, and then our negative 2. So we're starting at negative 2. And it's a positive 1 slope, which means one up, 1 over. So it's a perfect 1 slope. So you just go diagonal through the dots. And I'm going to go this way as well, just so I can see where does it cross this red line. So I'm actually going to extend my red line just a little bit more so I can make sure that I get the actual solution and not just my estimated one with my crooked line that I had earlier. So remember, this was 3 over 1, so we're going to go down 3, 1, 2, 3 over 1, and that's the solution right there. Oh. Mrs. Glenn, you can do a better line than that. That's a little bit better. There we go. All right, so now our blue line is going to intersect right here. And it changed black for some reason. I don't know why. I didn't pick black, but okay. So now we're going to make our line go through the blue. No, starting again. You have no idea how much I'm concentrating right now. Oh my goodness. Okay. There we go. So our solution is this green one right here. So we're going 1, 2, 3, 4, 5. So that's negative 5 to this line right here that it's on. And we're going down 1, 2, 3, 4, 5, 6, 7. So negative 7 because we went down. So to the left was negative and down was negative. So negative 5, negative 7, and that's our solution. So you make sure you circle it. And then for number 4, we have x plus 2y equals 4. So we're going to subtract x on both sides. And then you have to divide by 2. So this turns into y equals, and negative x over 2 is the same thing as negative 1/2 x. And 4 over 2 is just 2. So now we can graph that. So we have begin with b, so start at 2. And we're going to go down 1 because it's negative, and over 2. Down 1 over 2. Down 1 over 2, and so on. And you might want to extend it this way as well so that you can make sure Your point goes through that. I'm going to wait to graph this line just so I can make sure that I have enough for the second line. So this line's already in, or this equation's already in slope-intercept form, so we don't have to solve for y. So we're going to start at 2. Let's pick red. There we go. Start at 2. There's our solution because they're both at the same point. And then we go down 1 over 2 again. Look, what's happening. What's happening, guys? It's every single point is the same. So how many solutions is this if you remember from the previous page? So when we make our line, it's going to be the same line for both because they both share the same slope and the same y-intercept. If you notice, this equation is the same as this equation because it's the same line. It's just the second one was not in, or the first one was not in slope-intercept form. So it ends up being the same line, so we say infinitely many. And that's how many solutions there are. Every single point on the line is a solution of the other line. All right, number 5. I'm going to start out with the y equals -7, just because that one's easier. So 1, 2, 3, 4, 5, 6, 7. So if y is -7, then for every x value, y is going to equal -7. It doesn't matter. So it's actually just a line that goes through -7. I'm not going to make this line better on this side. You can tell what hand I use to write. My right hand's better than the right side is better than the left side. Oh, geez. Okay, that's better. This is covering most of the line. All right, so for this one, we would subtract x after we write it. So subtract x, you get 3y equals -x minus 15. Divide by 3. And this turns into y equals, and -x over 3 is the same thing as -1 over 3x. And then 15 divided by 3, and it's a negative, so it's -5. So that's our starting point. I'm going to change the color. So -5 is 1, 2, 3, 4, 5. And this is down 1 over 3. We always go to the right. The bottom is run to the right. Run to the right. Always going to run to the right. Okay, so if you want to be right, run to the right. You can say that if you want to. If you want to be right, run to the right. All right, so down 1 over 3. 1, 2, 3. Down 1 over 3. Here's our solution. Boom. 1, 2, or down 1 over 3. 1, 2, 3. Over 3, 1, 2, 3, up 1. So we can go to the left. Over 3, 1, 2, 3, up 1. So now we have our solution. Oh my goodness, Mrs. Klein. There we go. Okay. So our solution is right here. So we're going to go 1, 2, 3, 4, 5, 6. And that's in the positive direction. And then we go down 1, 2, 3, 4, 5, 6, 7. Let me just check that. 1, 2, 3, 4, 5, 6. Yep, 1, 2, 3. And I know this is 7 because this is the line -7 down there. So this is our solution. 6, -7. Make sure you circle it so that we know that's your answer. All right, number 6. First one is already in slope-intercept form. So we have starting at 5. 1, 2, 3, 4, 5. And we're going to use a slope of 1. So that's 1 over 1. So up 1 over 1. Now this, I don't know if I'm going to mess things up, but this has a line in it. I think. Here we go. Yeah. So we can use this as the line. Let's see if this works for me. I don't know. Nope. Alright, if I want to use this line, will you work? No, Never mind. Okay, so back to red. And I'm going to wait to put my line through this until I see what the other one is, just so I can make sure I have the solution. So let's do this one. So we would subtract x. You get negative y equals negative x plus 2, because this is a positive 2. So then we have to multiply or divide by negative 1. Either one's fine. I like multiplying because then I don't have to make another line to change everything. The reason why we're multiplying by negative 1 is because we're not solving for negative y, we're solving for positive y. And the only way to make a y that's negative positive is by multiplying or dividing by negative 1. So if we do it to one side, we have to do it to the other. So this turns into y. Negative 1 times negative x is a positive x. Negative 1 times a positive 2 is a negative 2. So now we have a slope of 1, and we're starting at negative 2. So b is negative 2, begin at b. So down 1, 2. This is a slope of 1, so we're going up 1 over 1, up 1 over 1, and so on. And if you notice, these two lines will never cross because they have the same slope. So if they have the same slope, it is parallel, so that means there are no solutions. Okay, so if we actually made this line, it would be like this for 1. And the red one would be the same thing. And they'll never touch. So there's no solution. The solution's only when they intersect, and there's no intersection. So there would be no solutions for number 6. All right, number 7. We have a couple things we got to do. We have to first subtract 3x. So you're left with negative 5y equals negative 3x minus 35. And then we're going to divide by negative 5 on everything. So this leaves you with y equals negative divided by negative is just leaving you with 3/5 x. Negative 35 divided by negative 5, negative and negative make a positive 7. So we're starting at 7. 1, 2, 3, 4, 5, 6, 7. And we go up 3 over 5. 1, 2, 3, 1, 2, 3, 4, 5. And I'm going to go down 3 over 5 just so I have another point over here. 1, 2, 3, 1, 2, 3, 4, 5. And I would recommend, if you wanted to make your lines really straight, use the side of a piece of paper so that it guides your pencil, or side of your folder, or even if you have a spiral bound notebook, the back cardboard or the front cardboard is a good edge to use to make your line straight. You can also test to make sure you have the right slope. Is if, like, you know how I'm doing this backwards to go to the left of the line, if I did that and when I lined up my paper and or my board of my front or back of the spiral bound notebook, if it didn't line up, then I know I didn't do this point right. So it's kind of like checking your work if you use your edge of your paper or notebook. All right, so this one we have the red line done. So let's do the blue line, which is 2x plus y. This one's an easy one because we just have to subtract 2x. So just subtract 2x and we're done. So you're left with y equals negative 2x minus 6. And we're going to start at negative 6. So 1, 2, 3, 4, 5, 6. And we go down 2 over 1. So down 2 over 1. Down 2 over 1. We're going to go over 1 up 2 to get to the other point to the left. There's our point of intersection. So that's our solution. All right, so if I make this line, oh my goodness. Start again. Oh, okay. Hold on. I can't do this, guys. It's not gonna work. All right, so I'm gonna start down here. Nope, that didn't help either. Let me start from the bottom up. We started off really good and now we're not doing so good. Oh, I'm just gonna keep this one because you saw the other ones. We're not gonna try this again. All right, so this is your source of entertainment during your math homework. Okay, so here's our solution. So we're going over -1, -2, -3, -4, -5. And then we go up, +1, +2, +3, +4. So there's our solution. Okay, I'm entertaining myself. So this one is x equals -2. So when we get to -2, every single point is going to be x is -2. So that means it's a vertical line. A very crooked vertical line. And then we have 3x minus 2y equals -18. So we're going to subtract 3x. And you're left with -2y equals -3x minus 18. Divide by -2 on everything. And you're left with y equals negative divided by negative is a +3 over 2x. -18 divided by -2 is a +9. So we'll start at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going up 3 and then to the right 2. So up 3, 1, 2, 3 over 2. And then down 3, 1, 2, 3 over 2. Here's our intersecting point, so that's our solution. Down 3 over 2, 1, 2, 3. And I just want to point out, when you're going backwards like this, you're not following this thing, you're actually following it backwards. So when you're doing it, like for here, I went up 3 over 2, but to get to this point, I would go, down 3 to the left 2. So it's, instead of going up, I'm going down. Instead of going to the right, I'm going to the left, because you're trying to go from where you started. So if you start here, you can still go up 3 over 2, up 3 over 2, up 3 over 2, like the slope is. So don't, accidentally do that originally and then get the wrong slope. So you can test your slope to see if you're right by looking at the slope if it's positive or negative. And this is a positive slope, so as we read the graph from left to right, we would be traveling up. So we know that we're correct on that. If I had a line that was going down, that means I did it backwards, and I shouldn't have done that. So this is correct because it's going up. So we have another point here, and then I can make my line. Or let's just say I can attempt to make it. Oh my goodness. Okay, I didn't breathe through that whole thing, and I did a lot better. Maybe just breathing is the problem. All right, so point of intersection is right here. So we are over -1, -2. And we're up 1, 2, 3, 4, 5, 6. So that is our solution.